Hello, everybody. My name is Gaël Langevin. I'm a sculpture designer. I'm French, and I come from Paris. So I'm very happy to be here. But today, with the events that just happened in Paris, in my streets, I want to give a real thought to the victims and to their families and their friends that were there. If I'm here today anyway, it's because I really think sharing knowledge and having communities together to communicate and to give information is really bringing up the spirit level of humanity. And this project that I'm bringing over here is based on that. It's based on community and sharing knowledge. So it all starts in 2011. Oh, it's me that has the stuff, sorry. Yeah. It all starts in 2011 when I got a 3D printer, and I was asked by a big French car company in Paris to build a prosthetic hand. They wanted me to create, to design, to sculpt a prosthetic hand for a commercial. So I made a quote for this hand, but the job just didn't happen. So, because I think I was maybe too expensive or something like that, you know. So it didn't happen. Anyway, I had my 3D printer that you can see over here, and I also had the I'm losing my stuff. I also had software called Blender, which allows me to design the hand on open source. So I download the software, it's open source, I can create the hand, sculpt it, and then once it's ready, I can 3D print all the parts on my machine. So it's a very small machine. It's not a huge machine like industrial systems and stuff like this. It's a small machine that fits 12 by 12 by 12 centimeter. So I realized the first hand, and once it's done, I print it. I test it, use Arduino system. Arduino system is microcontroller that allows you to control little motors, and it's also open source. So being able to move the hand with the computer or by voice, things like this, gave me the opportunity to see the potential of this hand. And at the time, there was no prosthetic hands 3D printed. It was in 2011, and I decided, because I had my open source software, the 3D printer that came as open source as well, I decided to share all the files of this hand with the people on the world. So this is, I'm going to go a little further. So this is the hand at some state. Sorry, I'm having trouble. Yeah, okay. So the software, the system, the place where I can upload the parts is called Thingiverse. It's a platform where everybody can download the pieces and they can reproduce it. So they were able to make the same hands over and over and create different things on it, put sensors, add some other motors than the one I had chosen, and so on. So after that, because I was sharing this hand, I decided to go on learning more about Arduino and coding and scripting and things like this. And I designed the bicep of the robot. This is one of the first versions. Then later, I modified some parts and added the shoulder system. All those parts that you can see over here are also 3D printed. So I make sure that it's like a Lego system. All the parts are 12 by 12 by 12 centimeter, and they fit on any home printer. So it's or snapped together, or with a screw, or a system like that. I have a huge thing here, and actually I only need to press that little button to make the things. See, but it's going wrong every time. Yeah, so this is the state where the robot is at this moment. So you can see all the components, like On the torso, there's small parts. On the front, it's also small parts. The eye system, the mechanisms, it's all 3D printed, as well as the shoulder mechanisms, the gearings, the bearings, everything is 3D printed. So what happens is that at one moment I had 2 hands with Arduino boards, so microcontrollers, and they were independent. They couldn't work together. So I went looking again on the internet and searched for software that would give me the possibility to synchronize all of that together. So I found a software called MyRobotLab. It's also open source. The project is open source, so that's my goal. So I found a software that is called MyRobotLab, and I tried to look in it. There's many softwares that are expensive, very complicated about robotic, but this one, I thought maybe I can work it out. So I contacted the guy, he's called Greg Perry, and I said, okay, I've got 2 controllers here. Is it possible, you think, to synchronize this together to make it work? And he said, sure, by email. So I thought, wow, this is great. So I'm going to be able to make a code, and the 2 hands are going to move together. So that's how it worked. And from then on, I worked with the software MyRobotLab. So we've been adding 2 cameras in the robot. There's a Kinect on the torso that allows to see in 3-dimensional. There's also 28 servos in total on the robot, which allows him to make movements. There's a PIR sensor for detections of movements, 10-finger sensors that allows him to touch objects and to detect the pressure he's doing on a bottle or something like this. Let's try to go to the next one. Yes, it worked. So every time I design, sculpt a part, I put it on the website and make sure that everybody can benefit of what I'm doing. So at this stage, it's going very, very fast. There's 55 countries that are building the robot. There's 85 universities. We don't know exactly, because not everybody is reporting themselves on the map, but it's going very fast. We estimate that there's about 200 clones in the world of this robot. So it's some parts, it's only the head with the torso or with the shoulders. Some of the parts, it's 2 hands. But it gives the opportunity to create a lot of projects. It can be prosthetics, it can be learning between humans, the reactions, and the robots. It can be vision tracking and things like this. So, because it's open source, I really think the only way to make something open source, really open source. There's many projects, they claim to be open source, but actually they don't share anything. So what I do, every time I design something, I put it on the website, but then I create a tutorial for the people to be able to understand how you assemble the parts together and to connect things and to have the connections, electrical connections, and so on. So this is really based on educating people how to proceed to build their own robot. So I'm going to show you some examples. Okay, it's supposed to move normally. It's GIF pictures. Normally they're supposed to move, but it's not moving. I'm going to show you some examples of things that have been done until today with the hand. So you can see on the top, on the left top, it's a hand that has it's not tension, it's curving sensors. So when you curve the finger, it can give the information as code. You can see on the bottom left, it is brain controlled. So actually this is normally a little video that moves. So you can see the person is controlling with his brain and the hand is closing on the object. On the other side is somebody showing the system with the sensors and the motors inside the hand in a school. There it works. So you can see he's controlling the hand just with his brain. Very interesting. Let's go to the next one. So in this one, it's many prosthetic projects. They are done or by schools, universities, but there's also some makers. That means it's somebody in his garage, he downloads the files, and he starts to put the things together and screw the things together and follow the tutorials, and he's able to do some prosthetics. So this is really bringing a whole new edge. You know, it's bringing the possibility to anyone to build something that before was not possible. You had to buy the parts, or you had to buy a system, or you had to build it yourself, but you couldn't share it with the other one. So on the top right, it's Nicolas Huchet. He's handicapped. He lost his hand when he was young. And so he downloaded the parts as well, and we figured a way to set up the motors outside his limb. So like this, he could actually control with the myosensors the hand. So this is the first prototype, but there's more to come. And he has won many awards, like the Google Awards recently. Let's go further. So because it's used in prosthetics, I said to Nicolas Huchet, I said, the first hand, is made with cables, and it's not really reliable. So I designed a new hand, which is this one. And this new hand includes the motors, includes the microcontroller, includes the Myo board, which means you just have to send a signal to the hand, and then the hand is able to move. So you will see in the video over here, on the right, on my forearm, I'm wearing a bracelet, black bracelet, and that bracelet works as Bluetooth Myo sensor. So when I'm moving my hand, it actually moves the hand. So the hand is receiving the data automatically by Bluetooth. There's no connection beside the wire that you can see plugged on the hand to give the power to the hand. So it can be a battery or something like this. Actually, at the moment, it's the computer that is powering up the hand. So it stopped. Yeah, I guess you've seen enough. All right, so what happens also is, because it's not only the hand, it's the whole robot, people start to build the robot, and then there's some people, they thought, okay, this robot is really big, it's the size of a human, so why don't we make a smaller version? So this is the case. The top on the left top, it looks a bit scary, it has weird eyes, you know, but it's interesting because all the parts have been reduced to 64%, and so we are able to have a smaller hand, which also can be used to search for children prosthetics. Everywhere in the world, they download the robot and they make it their own. So that's the interesting thing. At first, when I saw the pictures of people, I thought, oh, I've designed a robot that is black and white, that is nice looking, with a nice color matching and so on. And then I thought some of them are weird, you know, they have strange colors. But I think today, that's the interesting thing, is that they make colors, they change the face, they change the eyes, they change everything, and it's becoming their own robot. Actually, they even give a name to their robot, so it's really something happening. So on the left corner, it's in Russia. This guy normally works in nuclear system, and he downloaded the robot and he starts to build it. In Poland on the right top, and in Georgia on the left. And on the right, it's a kid that has lost a hand, and they are trying to see if he's able to use his muscles to move the hand. So he's able to remember his finger muscles. More colors, isn't it? So there's more colors. On the top left, it's in England. This one is built in a school by children. In the middle top is in Russia as well, in a school. So the kids are of an average between 8 and 15 years old. So they are able, it's like Lego, they build up the thing together, they start to program it, and so on. On the top right, it's in America. So the person that made this one has shared a code which allows us to use the Kinect on the robot, so he can see in 3 dimensions. On the bottom left, it's Italian, and then the black one is in Holland, Amsterdam. This is only just some examples. You can imagine on 200 clones, how many colors you have, how many differences you have. Some, they already started to put some mask on them, like silicone things. Some are looking really awful, but that's the way it goes. So you see there's a red one, there's a black and white, there's green one like a frog. So we are also doing it on wheels. You can see on the top, the golden one, like the CP03, it's on wheels. It also can speak and have loudspeakers. The one on the left side, bottom, can ride around and is able to detect its environment. The one in the middle, let's try to make it move. It's mine at a certain point. I'm using the Kinect, so the way it works, I move some gestures on the front of the robot, and he's copying my gestures. Is it working? Yes. So the robot is trying to copy what I'm doing, and then with the voice, I'm able to say capture gesture, and then he registers the positions of the motors, and you are able to reproduce those movements afterwards. On the top right, it's a kid, 15 years old. He has built up this robot all by his own, and he's from Greece. On the right, it's somebody starting to build some legs, and it's in Russia. So the robot is used in various projects. On the top left, it's the CAST project that won the DARPA project this year. They try to make the InMoov flight a plane. So I tell you, I don't want to be in that plane, but because it's like a bit scary. On the right, let's see which one is going to work. So this one is me controlling the hand just with a leap motion. So it's an infrared system. You just put your hand over, and it detects your fingers in the air, and so you're able to make it move. On the left bottom, he's learning the hand to play rock, paper, scissors. And from that, I'm able to make the robot shake hands. Okay, let's see. And then, of course, because it's a human robot, sometimes it has to ride in the car. So I like those pictures because I think it's pretty funny. It's people, they are going someplace with their robot, and they have to attach it with the seat belt anyway, so just in case the police stops them. Okay, at the current steps, I'm working on the legs to really have a system that is steady, also 3D printed, with motors that are not so expensive, and a system that anybody can download as well, that is available for everyone. So that's a very hard step, to make the robot stand on its own, to be able to be fast enough, and to make it low price. So it's a real challenge. We are using InMoov also as virtual learning. So that means we use a Kinect. For example, my robot is in my workshop, and it's standing on the front of a mirror. And then Alessandro on the bottom, he's looking through the Kinect, and so he's able to see through the eyes of my robot in my workshop. So when he's making some movements, he can see actually the robot in my workshop moving. I don't know if you get that, but it's virtuality. So you're going to see he's moving. When he's moving, the robot is moving. So this one is next to him, but there's one in my workshop that does the same thing. So that's telepresence with Oculus Rift. We can use the leap motion, the Thalmic, which is the black ribbon that is on the forearm. And we have a project in London where kids that are hospitalized, they cannot come out of their room because they have an illness that is, they cannot go outside because of contagious. And so what happens is we have a robot that is standing outside, and they use the Oculus Rift and some kind of remote control like this, and they are able to move the robot around. So like this, they can see in a zoo or aquarium, something like this. This is a project. We are working on it. It's not ready yet, but it's an idea that we have and that is getting worked on. So the immediate challenges on this project is to make a calibration for all the robots. what happens is that one is building the shoulder a little bit to the left, the other one is putting the motor a little bit like that. At the end, the same scripts don't control the robot the same. So when you're going to say arms up, one is going to go like this, and the other one is going to go like this, and so on. So we are trying to set up a system so all the robots, they can calibrate themselves to start, to be able to reproduce all the same gestures. The ability to seamlessly identify objects and their bodies, so like this, that's part of the calibration. It means you have the robot standing on the front of a mirror, and then when he's moving the hand, he's able, through these cameras, to see his hand moving. So when you have a black and white object on the hand, so he's able to control and see the distance from his body. So that's one of the part of the calibration that we are working on. To be able to learn sequences and movement based on human models. So using the Kinect is one of the things, but we have a system that is a little bit slow, which needs to be improved. Maybe with the new Kinect that are coming up, like Kinect 2, maybe we're going to be able to make some improvements on that. The voice. Voice is a very difficult thing, because today I'm here and it's not so busy. Normally the robot should be able to understand what I say. But when I'm in an environment where there's a lot of music, like a concert, and I have to come with the robot and show it, of course, the robot doesn't get it at all. So we need to find a system for the microphone to really detect and separate what is noise and the real voice. And we are working on deep learning machine in Paris with the school that are trying to enforce some codes and algorithm to make it go much faster on a small computer. So the next steps is to develop an open source data center for all the robots to be able to connect themselves. So the idea, when I show a ball to my robot, a green ball, I tell him this is a green ball. So he sees the ball, he memorizes it as a color, as a form, and then as a word. That's 3 points. Later, when another robot in America, you show him the green ball, he should be able to see the ball and say, it's a green ball, isn't it? So that's one of the things. Creating the base of an artificial intelligence, that's a big word. Really, seriously, it's computers for today, so we have a lot of work to do on this, seriously. Satellite-based environment recognition and locomotion. So the idea is to have the robot, when he's moving here, so go forward. I'm going to help him to come. Yeah, go forward. Oh yeah, I need to put on my microphone. It's so much things to control.
Did you say? What is it?
No.
Sorry.
How do you do?
Did you say? Drop it.
No. You see, there, even there, he hears all kinds of things.
Sorry.
So this, you can see all the parts over here are 3D printed. So I'm controlling it to make it move with this. That's
Did
only for the wheel system.
Voice control.
No.
Sorry.
How do you do?
I'm fine, thank you.
Nice.
Yes, indeed.
I'm going to disconnect this so he stops right behind.
Did you say? Open hand.
No.
Sorry.
Cycle gesture 3.
Did you say? Cycle gesture 3.
Yes. Yes.
Okay.
So you see, each fingers can move separately. He has a motor for each finger. Then there's all the gearings inside are 3D printed as well, so it's all plastic. He's able to do ninja on the scene. That's pretty amazing, isn't it, with the 3D printer? So you can see the cameras over here in the eyes. They actually are looking. Camera on. Camera on. Oh yeah, of course, I stopped to talk.
Did you say? Perfect.
Yes.
Wow, I feel good. I love this.
Camera on.
Did you say? Camera on.
Yes. Yes.
Okay.
Track.
Did you say? Track.
Yes.
Okay.
I'm going to go on the other side.
Did you say? Arms front.
Yeah. You see, I have to cut my microphone, otherwise he hears what I say, and then he starts to do all kinds of different things. So there you can see he's moving the eyes separately than the head. So there's a system, a PID system, which controls first the eyes and then later the head. Delicate grab.
Did you say? Unhappy.
No.
Sorry.
Delicate grab.
Did you say? Delicate grab.
Yes. Yes.
Okay.
Is it a ball?
Did you say? Is it a ball?
Yes.
Did you say? Who's there?
Is it a ball?
Did you say? Is it a ball?
Yes. Yes.
Okay.
So at this, wait, I'm going to turn off the microphone. So at this stage, normally he's able to see the ball. And so
I have no idea. I am not connected to internet.
Oh, yeah.
Did you say? Unhappy.
Sorry.
It doesn't matter. Sorry.
Oh, yeah, you're sorry too.
Did you say? Release delicate.
Yes.
Okay.
Thank you.
My pleasure.
How do you do?
Did you say? Unhappy.
So when he's going like this, wait, turn him off.
Did you say? What is it?
When he's going unhappy, it's because he gets some noise and he thinks there's too much noise, so he doesn't understand what's going on. So he gets unhappy very often, actually.
Sorry.
How do you do?
Did you say?
Oh, he doesn't
Unhappy.
get that. No.
Did you say?
Okay.
What is it?
Rest?
Did you say? Rest.
Yes. Yes.
Okay.
Grab the bottle.
Did you say? Drop it.
Grab the bottle.
Did you say? Grab the bottle.
Yes.
Okay.
So with
Did you say? Unhappy.
with the finger sensors, he's able to grab the bottle and he's able to give a certain pressure on the bottle. So if I go like this, he's holding the bottle. Release delicate. Release, oh yeah, I forget every time.
Did you say? Camera on.
Release delicate.
Did you say? Release delicate.
Yes.
Okay.
Wow. Thank you.
My pleasure.
What about Star Wars?
Hello, sir. I am C-3PO Human Cyborg Relations.
I love you.
I love you too.
Hey.
Did you say?
Okay.
What is it?
So actually,
Did you say? Track.
the idea is really to be able to have everyone in schools, in universities, to be able to reproduce this robot. So on the website, you can find all the parts, all the tutorials, all the informations to be able to make, oh yeah, I forgot some pages, I'm sorry. This is in the press. And this is what I want to show you. Okay. So you, if you want to build a robot, just come on the website, download the parts, and start to build it. Okay?
Sorry.
Thank you very much. Thank you, guys.
Preguntas, bien para Gaël, bien para C3PO. Venga, un micrófono aquí, por favor.
Did you say?
No.
Perfect.
Thank you. What
It's all mute.
kind of personal relationship do you have with them?
Well, this morning when I was in the hotel getting him ready, because actually I travel with the robot in suitcases, so I have to separate the arms, separate the heads, separate the bottom, separate everything. I'm a little bit like Dexter, do you see? And so when I put him together again in my room in the hotel, I really have to go, it's going to be okay, you're going to work. But to answer more, there's people that really give the name. Actually, the project is called InMoove. So this one, that's the first one, it's called InMoove. But most of the people, they give a name. So there's a Mark, there's a Jerry, there's all kinds of names. Everybody's giving names to their robots.
Yeah, I wanted to know how long it took from the idea to get it to this.
So I started in 2011 with the hand. Within 6 months, I had built up this part to the shoulder. It went really fast because I was really eager to go on and make some tests and so on. And then it has slowed down pretty much since a year and a half because I've made the new design of the new hand, which is pretty complex. And also because the community is so big that I had to take care of this, to arrange the website so the files would be available easily and so on. So it's 3 years of work to design the parts, to sculpt them, to print them, put them together, make some tests and so on, and then share them.
¿Alguna otra cuestión? Sí, no, por aquí. La última ya.
Hi.
Hi.
One of the big questions of AI at this point is, have you considered the risks of having an open source AI database?
Did you say? Camera on.
No. The AIA base, it's mainly on the software. That's where we are working on. There's not really, at this moment, there's not really artificial intelligence. You see, he's responding with programming, so there's a system more like a chatbot, like your telephone, when you're talking to your telephone, that's the way it works. But that's what we want to do, is to really have something to open source, to have information, scripts that you can add to your own scripts. So like this, it's going to give more functionalities, more database, and it's going to be able to go and gather things on the internet to have more information and more knowledge, if we can call that knowledge. Yeah?
Okay, the last one. Una pregunta más aquí. Hola. Sí, aquí.
Hi.
Hi.
Is there, or do you expect any kind of regulation on building and driving robots as the way we see on drones, the way building drones or flying drones? Because, I mean, it seems you have a kind of an army of robots. So maybe it's a secret instruction in the firmware.
Yeah. Well, I think the main idea is why I'm sharing this thing is not to create an army. It's because I think if we all build together robots, if schools build robots with me or with the other guy or the other school that is in Spain, for example, together they're going to put things inside the robot that we are conscious about. We know what we are doing together. Do you see? I feel like it's more a big company that is building a big robot going to sell it to you, those guys maybe are going to make some army robots. Do you see? No, I think it's one of my feelings. I have faith in humanity, even though with what's going on actually in Paris, I do have faith. And I think sharing ideas brings up ideas, and it gives knowledge to other one to be able to construct over what you have built. And it has been like this since always. If we are here today, if the system, the society is like this, it's because we have knowledge based on the past and so on. So I think sharing information and knowledge is one of the keys for our future.
Good to know. Thanks.
Thank you.
Bien, acabamos aquí. Gracias, Gaël. Thank you.
Based on that, it's based on community and sharing knowledge. So it all starts in 2011. Oh, it's me that has the stuff, sorry. Yeah. It all starts in 2011 when I got a 3D printer, and I was asked by a big French car company in Paris to build a prosthetic hand. They wanted me to create, to design, to sculpt a prosthetic hand for commercial. So I made a quote for this hand, but the job just didn't happen. So, because I think I was maybe too expensive or something like that, you know. So it didn't happen. Anyway, I had my 3D printer that you can see over here, and I also had the, I'm losing my stuff. I also had software called Blender, which allows me to design the hand, one of the first versions. Then later, I modified some parts and added the shoulder system. All those parts that you can see over here are also 3D printed. So I make sure that it's like a Lego system. All the parts are 12 by 12 by 12 centimeter, and they fit on any home printer. So it's or snapped together, or with a screw, or a system like that. I have a huge thing here, and I only need to press that little button to make the things. See, but it's going wrong every time. Yeah, so this is the state where the robot is at this moment. So you can see all the components, like on the torso, there's small parts. On the front, it's also small parts. The eye system, the mechanisms, it's all 3D printed, as well as the shoulder mechanisms, the gearings, the bearings, everything is 3D printed. So the 3D printer that came as open source as well, I decided to share all the files of this hand with the people on the world. So this is, I'm going to go a little further. So this is the hand at some state. Sorry, I'm having trouble. Yeah, okay. So the software, the system, the place where I can upload the parts is called Thingiverse. It's a platform where everybody can download the pieces and they can reproduce it. So they were able to make the same hands over and over and create different things on it, put sensors, add some other motors than the one I had chosen, and so on. So after that, because I was sharing this hand, I decided to go on learning more about Arduino and coding and scripting and things like this. And I designed the bicep of the robot. This is on open source. So I download the software, it's open source, I can create the hand, sculpt it, and then once it's ready, I can 3D print all the parts on my machine. So it's a very small machine. It's not a huge machine like industrial systems and stuff like this. It's a small machine that fits 12 by 12 by 12 centimeter. So I realized the first hand, and once it's done, I print it. I test it, use Arduino system. Arduino system is microcontroller that allows you to control little motors, and it's also open source. So being able to move the hand with the computer or by voice, things like this, gave me the opportunity to see the potential of this hand. And at the time, there was no prosthetic hands 3D printed. It was in 2011, and I decided, because I had my open source software. Hello, everybody. My name is Gaël Langevin. I'm a sculptor designer. I'm French, and I come from Paris. So I'm very happy to be here. But today, with the events that just happened in Paris, in my streets, I want to give a real thought to the victims and to their families and their friends that were there. If I'm here today anyway, it's because I really think sharing knowledge and having communities together to communicate and to give information is really bringing up the spirit level of humanity. And this project that I'm bringing over here is